Right, Eg17 then. So plot the graph of the following parametric equation. So you can see here that we've got a pair of equations which will produce an x coordinate and a corresponding y coordinate for a given parameter t. So that we've got that third variable t. Okay. Now if we want to plot that, what we do is we choose a range of values of t, substitute the value of t into the x equation and the y equation in order to produce a set of coordinate pairs that we can plot. Okay, so we're going to choose a range of values of t to calculate points x, y, and then we plot those. Now the range of values of t that you will choose, you will almost certainly be given, okay? Because otherwise you won't really know where to start. So for this particular equation, we're going to take values of t from -4 to 4. Because I know what's coming. So those are the parameter values that we're going to use, and using those we are going to work out the corresponding x and y values. So if we put -4 into x, we're going to get -4 squared, which is 16. And if we put the t value of -4 into the y coordinate equation, we're going to get -8. So that's going to produce the coordinate 16 minus 8. -3 squared is 9, -3 times 2 is -6. So that would be the coordinate 9 minus 6, 4 minus 4, 1 and -2, 0 and 0, and then 1 squared and 2, and then t is 2, so 2 squared is 4, 2 times 2 is 4, 3 squared is 9, 3 twos is 6, and 4 squared is 16, 4 twos are 8. So that's the set of coordinates that we can plot on a Cartesian axis. And what we've got there is x is ranging from 16 to 0. So on my axis, that needs to go up to 16. And the y is going as negative as 8 and as positive as 8. So I want it to go like that. So that's what I'm going to fit onto my graph. So if I want to go up 2, 4, 6, 8, my y-axis, -2, -4, -6, -8, 0, and then 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15, 16 will fit on there. So if I go 2, 4, 6, 8, 10, 12, my eyes are going to go googly now, 14, 16, x. Okay, so I've got a 0, 0, then I've got a 1, 2, and I've got a 1, -2. Then I've got a 4, 4, and a 4 minus 4. I get a 9, 6, and a 9 minus 6, and I get a 16, 8, and a 16 minus 8. Okay, so what this is going to look like is, if we draw a smooth curve through those points. So if it was that way up, you recognize it straight away, but it's like that. Okay, it's called a parabola. It's one of a family of curves called hyperbolic functions, or conic sections, that part of the further maths course, not part of our A-level course, but certainly something, if you do end up following maths later on in uni, that you will probably be covering. Okay, so that's what that looks like. And then part B, by eliminating the parameter, find the Cartesian form of the equation. So the Cartesian form would be one that just links x and y. It's the format that we're most familiar with. So the way that we do that, so there's my first equation, there's my second equation. Okay, now I can rearrange equation 2 to give me t equals. So t equals y over 2. So if I put that in 1, so x will be t, which I can now replace with y over 2, all squared. So x is y squared over 4, or y squared equals 4x. So that's the Cartesian form. Okay, and it's a general form of a parabola, as I said, parabola. That would be an equation of a parabola. And what makes that different from most of the equations that we've plotted in the past is they've always been y equals something, and it tends to be that it's the x that is squared or cubed or whatever, and the y is always just singular. With a parabolic equation, it's very often the y part of it that is squared. Okay.